look at this example of a linear programming problem where we had the constraints 4x plus y is less than or equal to 40, 20x plus y is greater than or equal to 72, and 4x plus 5y is greater than or equal to 72, with the objective function is z equals to 3x plus y. So the first thing to do is to draw your feasible region. So what I would first do if I were doing this problem by hand is find your x and y intercepts for the lines 40x plus y equals to 40, and then if the other ones were equals as well. Now, one thing to note, since all of these are less than or equal, greater than or equal, that we draw solid lines for the three lines. So for the first one, I would have the x-intercept would be the point 10, 0. Remember, to find your x-intercepts, you let y be 0, solve for x. For my y-intercept, if I let x be 0, solve for y, I would have the point 0, 40. And then, doing the same thing for the next line, I would have the point 72 over 20, which would be 3.60. And I would have the point 0, 72. And then, looking at the third line, if I let y be 0, solve for x, I would have the point 18, 0. And if I let x be 0, solve for y, I'd have the point 0, and it would be 72 over 5, which would be 14.4. So since these aren't exact values or anything like that, like it's not all integer values, and also some of them are pretty large, I'm going to just put approximate values of where those would be on the number line. So let's see, let's say that this is 3.6 over here. Let's say that this would be 10, and then down here would be 18. And let's see, for here, let's say that this is 14.4, then higher would be 40, and then higher than that, let's see, 72. So, and then drawing the lines, let's see, the first one goes through 10, 0 and 0, 40. So that would be that first one. And then for the second one goes through 3.6 and 72. Obviously, when you're doing this, it'd be better if you did this with a ruler as well. And then, let's see, for the last one, it goes through those other points. So those would be my three boundary lines, and then we got to find out what is a region bounded, if it is bounded, or satisfies all three inequalities. Well, let's see, it's supposed to be less than or equal to 40, so it's going to be to the left of the red line, and the other ones are greater than or equal. It's going to be to the right of the blue and above the green line. So the feasible region in this case will be that triangular region here. And again, remember, when you're trying to figure out what side of the line is, you could often use the point 0, 0, the origin, to see does it satisfy the inequality, and if it does, then it's on that side of the line, and if it doesn't, then it's on the other side that doesn't include the origin. Okay, so we have this is our feasible region. Now we got to find the corner point. So we have let's use black. So we have these three corner points here, so we got to find those. Let's call this, let's just call this A, B, and C, where A is the intersection of the red line and the blue line, where that's the first two equations. So for A, we're trying to find the intersection of the first two lines, which would mean, okay, solving the system 4x plus y equals to 40 and 20x plus y equals to 72. I can use the substitution or the elimination. Can't really use it by graphing because we really eyeballed that, so we really don't know the exact values. So what I would do is I'll probably use the elimination method because I could just multiply the second equation by -1. Add the two. Actually, let's multiply the first equation by -1. So we'd have negative 4x minus y equals to -40, and combine that with 20x plus y equals to 72. Do that, we get 16x equals to 32, so x would equal to 2. Plug in x equals to 2 into either one of the original two equations. Let's say the first one, we get 8 plus y equals to 40, so we'd get y equals to 32. So that corner point is a point 2, 32, which makes sense from the position of that point on the graph. Now the point B, that's the intersection of, let's see, the green line and the red line. So that would be the intersection of the first and third equation. So that would be the 4x plus y equals to 40 and the 4x plus 5y equals to 72. So solving that system, let's multiply the first one by, let's say, -1. So we get -4x minus y equals to -40, because that's why we're eliminating the x's. And so we have 4x plus 5y equals to 72. So combining the two equations, we get 4y equals to 32. So y would equal to 8. Plug in y equal to 8 into either one of the equations. Let's say the first one, we get 4x plus 8 equals to 40. Solving for x, you get x equals to 8 as well. So we have the point 8, 8. And that looks reasonable from our sketch. And for the last point C, that's the intersection of the blue and the green one. So that would be the line 20x plus y equals to 72. And 4x plus 5y equals to 72. So what we could do is let's multiply the second equation by, let's see, -5. That way we'll eliminate the x's. So we'll have 20x plus y equals to 72. -20x minus 25y equals to -360. Let's see, so the x's are eliminated, so we get -24y equals to -288. Divide both sides by -24, you get y equals to 12. Plug in y equals to 12. Let's say into the first equation, we'd have 20x plus y equals to 72. Subtract 12 from both sides, divide both sides by 20. You get x equals to 3. So we have the point 312, which again, that looks good from our sketch. So what we do next is we're trying to find the maximum and minimum of this linear programming problem. So what we do next is we plug in our corner points into our objective function, and since it is a bounded region, we do have both a maximum and a minimum value, and again, that occurs at one of the corner points. So again, we have the objective function as, once again, z equal to 3x plus y. So plugging in the point 232, we'd have z equal to 3 times 2 plus 32. So that would be, what, 36. Plug in the point 8, 8. We'd have 3 times 8 plus 8. So that would be 32. And plug in the point 312. That'd be 3 times 3 plus 12, so that'd be 21. So this tells us that our, let's see, our minimum value is 21 at the point 312, and our maximum value is 36 at the point 232. I hope this helps.